All right, complex numbers are written in the form a plus bi. That doesn't look like an a. A plus bi, right? So here we're adding two complex numbers together, right? And this video is going to be about adding, subtracting, and multiplying complex numbers. So for adding complex numbers, right, this is going to be 7 minus I, right? There's really a 1 out in front here. So you can just distribute the 1. 1 times 7 is 7. 1 times negative I is I, right? You can just get rid of the parentheses or think of it as distributing a 1. Okay, there's really like a 1 in front of here as well, but you don't really need to think of it that way. Just positive 1 times negative 9 is minus 9. Positive 1 times 3i is going to be plus 3i, right? And then from there, we just need to combine like terms. 7 minus 9 is negative 2. Negative I plus 3i is going to be plus 2i. Okay, so there's my answer written as a complex number, a plus bi. All right, let's look at a subtraction one now. All right, so a subtraction one, again, there's a 1 out in front here. So we can distribute that 1. 1 times 8 is 8. 1 times 4i is just 4i. So again, you can think of it as getting rid of you don't need the parentheses, or you can think of it as distributing a 1. So I'm going to have 8 plus 4i. Okay. We can, again, you can think of a negative 1 out front here. So we can distribute negative 1 times 9 is negative 9. Negative 1 times negative 3i is going to be plus 3i. And then we just combine like terms. So 8 minus 9 is negative 1. 4i plus 3i, 7i, right? We want to write it in the form of a plus bi. That's how we write complex numbers. Okay, let's look at multiplication now. So that was addition. This was subtraction. Let's go to one that might be multiplication. Excuse me. Okay, 4i plus 8i. So all you're doing is multiplying this just like if it was 4x times 8x, right? 4x times 8x is going to be 32x squared, right? 4i times 8i is going to be equal to 32 times I squared. The only difference is we know that I is square root of negative 1, which means that I squared, which is square root of negative 1 times square root of negative 1, is going to be equal to negative 1. I squared equals negative 1. So now x squared you couldn't do anything with. I squared, though, we can substitute in negative 1. So we can do 32 times negative 1, which is going to give us an answer of negative 32. Okay, perfect, just like that. All right, let's look at another example. All right, here's another example. We have 5 times quantity 3 minus 2i, so we need to distribute. So 5i times 3 is going to be 15i. And then 5i times negative 2 is going to be negative 10i squared. So whenever we have an I squared, we need to substitute in negative 1. So I'm going to substitute in negative 1 here. That gives me 15i plus 10. Okay, and then we want to write this in the form a plus bi. That's how we write complex numbers. So I need to switch the order so that a is first, and then b times I is second. A plus bi. So my answer here would be 10 plus 15i. Okay. All right, let's do one more multiplication one here. Okay, so I have doing binomial distribution, just like I would do with x, right? So 7 minus 2i times 7 plus 2i. Let me write it out here. Okay, and this again is going to be exactly the same as 7 minus 2x would be times 7 plus 2x. Right? If we do this, we would do first 7 times 7 is 49. 7 times 2x is 14x. That's outer. Inner, negative 2x times 7 is minus 14x. And then negative 2x times negative 2s is negative 4x squared, right? These would cancel and you would get 49 minus 4x squared. Okay, we're doing the same thing here, except instead of x squared, we're going to have I. And if we get an I squared, we need to substitute in a negative 1. So we're going to do 7 times 7 is 49. Plus 14i minus 14i. We do negative 2i times 7, and then minus 4i squared. So our 14i and our positive 14i, negative 14i cancel out, and I'm left with 49 minus 4i squared. For I squared, though, I can substitute in a negative 1. So now I have 49 plus 4, which gives me 53. Okay? Which is a real number. Okay? So our answer, though, it says a plus bi, but in this case, our answer is a real number, which is just 53. Okay, let's look for one that'll give us a complex number. This one will give us a complex number, so let's try this one. So if we distribute, 3 times 8 is 24. 3 times 4i is plus 12i. I times 8 is plus 8i. And then I times 4i is plus 4i squared. Okay, so I get 24 plus 20i plus 4i squared. Whenever I have I squared, I can substitute in negative 1. So that's plus 4 times negative 1. And that gives me 24 minus 20i minus 4, which is going to give me 20 minus 20i. Right? Because we want to write that in a plus bx, right? A plus bi. And there you go. So only thing different than this, than normal, is when you get I squared, you got to substitute in negative